Hey class, Mr. Houston here, back for another exciting episode of Geometry Notes. We're winding down here in our units on circles. Today's lesson though is all about the segment lengths inside of a circle, or in a circle. We're going to be using a couple of different theorems here, so make sure that you keep filling out that theorem worksheet page as we go along here, as it will help you on your quizzes and your tests. Okay, so the first one, we are talking about Theorem 1014, segments of chords theorems. So if two chords intersect in the interior of a circle, the product of the length of the segments of one chord is equal to the product of the lengths of the segments of the other chords. So what that is saying is from the intersection point, so we have AE and EB, that product will be equal to EC times ED. So if we put numbers to it, let's say this is 3 and this is 6, this may be 2 and this may be 9. So EA is 3, EB is 6, EC is 9, and ED is 2. 3 times 6 is 18. 9 times 2 is 18. So those will equal out. So that's just something that takes place inside of a circle with segments of chords. So let's put that into use. We're going to do a little algebra here. They want us to find ML and JK. So the first thing we have to do is we have to look at our segments. Okay. So the first one we're going to say is x times x plus 4, because those are the segments on KJ, is equal to, now we're looking here, let's change colors. Now we're looking here and here, so we'll say x plus 2, oops, forgot the 2, times x plus 1. So we will distribute on this side, so x times x times 4, so we get x squared plus 4x. And then we have to FOIL on this side, so we do x times x, which is x squared, x times 1, which is just x, 2 times x, which is 2x, and then 2 times 1, which is just 2. You should see that we have to combine like terms there, so x squared plus 4x stays there, x squared plus 3x plus 2 on this side. Hopefully, if you've done it correctly, you'll end up with an x squared on both sides, which will cancel out. Technically, you'll subtract them from both sides, but we just need to know that they're going to cancel each other out. So what you're left with is 4x equal to 3x plus 2. So we got to subtract 3x from both sides, and that's going to leave us with x equal to 2. Now, they didn't ask us for x, they asked us to actually find the length of ML and JK. So however you want to do this, we know that x is equal to 2, so every spot over here where we see an x, we are going to plug in a 2. So I can see that this is going to be 2 right here. Oh, that's a very poorly written 2. Let's try that again. A 2 right there. This is going to be 2 plus 1, which is 3. This is going to be 2 plus 4, which is 6. And then 2 plus 2, which equals 4. So ML will be equal to, this is ML right here. We had 4 and 3, so ML is equal to 7. And then JK will be equal to 2 plus 6, which is 8. Okay, so nothing that we haven't really done before with multiplying and simplifying, getting x's all on one side, but just a little more confusing, so just make sure you understand what it is we are trying to accomplish there. All right, let's take a look at our next informational part here. If we remember, a secant was a line that intersected a circle at 2 points. So if we look here, we have a secant. We have the what's known as the external segment, and then they don't talk about it in here, but this would be known as the internal part of it. okay, but the entire one is a secant. And then we have a tangent secant, which remember only intersects the circle at one point. Okay, so if we have theorem 1015, if two secants share the same endpoint, so in this case E, outside of the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So let's break that down into layman's terms. They meet at a common point out here. Therefore, the external segment EA times the entire segment EB will be equal to the external segment EC times the entire segment ED. Okay, so you're taking the external part times the entire segment and setting it equal to the external part times the entire segment. So we're going to put that action here with example number 2 on the back side of your notes. So what is the value of x? So again, just to reiterate, we have two secants, right? This is known as the external part for both of them. The entire thing is known as the secant. So our theorem states that the external part, so 3, times the entire segment, which would be times 3x, I'm sorry, not 3x, but 3 plus x, will be equal to the external segment, which is 4, times the entire segment, which in this case will be 4 plus 5, which in this case is 9. We know that's 9. So again, we have to simplify, distribute, so we get 9 plus 3x equal to 4 times 9, which is 36. We'll subtract 9 on both sides. We'll get 3x equal to 27. Divide by 3. X equals 9. So in this case, our answer is letter D. Again, just to reiterate that statement, the external part of the segment times the entire segment equal to the external part of the segment times the entire segment. That was 1015. Okay, and last, 1016 now talks about you have secants and tangents. So if a secant segment and a tangent segment share an endpoint outside a circle, point E, then the product of the lengths of the secant segment and its external segments, so the secant segment and the external segment, is equals the square of the length of the tangent segment. So breaking this down a little bit more for you. Taking what we did before, the external times the entire thing, is now equal to the tangent part squared. Okay, so when we had two secants, we did the same thing on both sides, external times the entire thing. When it's a secant and a tangent, external times the entire thing equal to the tangent squared. Again, please write these down on a separate sheet of paper, your theorem worksheet. This will be very valuable to you when you take your quiz. Okay? All right, so we are going to switch this problem up just because the way it's written is going to cause us some heartache here as we try to accomplish it. So let's just flip-flop these two. Let's call this 16, and we'll call this x. All right, so again, another reminder, I know I'm repeating this a lot, but it's important to understand how all of this works. The external segment times the entire segment is equal to the tangent squared. All right, so the external segment is 16 times the entire segment, which is 16 plus 8, which is 24, will be equal to the tangent squared. Okay, so the first thing we will do is determine what 16 times 24 is. We'll get 384 equal to x squared. Now, I don't know if you remember this or not, but in order to undo this part, we need to square root both sides. This one does not come out evenly, so I do want you to type it into your calculator. Square root of 384, and we would find that would give us somewhere in the neighborhood of 19.6. Okay? So again, lots and lots of information, lots of properties and theorems that you need to go back, you need to write down, you need to make sure that you understand. Should you have any questions, because I think you will, make sure you bring them with you to class. We have lots to cover when it comes to this, lots of practice that we're going to need to do, but make sure you have all of these theorems written down so that you can quickly access them for a quiz or a test. Any questions, bring with you to class. We'll see you then.